Good morning class and Miss Roy. Before I'd like to begin the video, I would like to thank Macquarie University for helping me a lot with this assignment. When I was researching for the topic of my assignment, I was looking for something fancy with a long name and sophisticated sound to it. As I was researching, I came across something called Astrophotonics. Long name, sophisticated, this is what I was going to do. Astrophotonics is the usage of photonic techniques and devices to gather light to better understand the universe we call home. Macquarie University uses astrophotonics to discover new exoplanets that are Earth-like. Currently, there are three methods I could find. The three are integrated photonic spectrographs (IPS), radio velocity, and integrated photonic lanterns. Let's start with the first one. Integrated photonic spectrographs are based on an optical chip and they fit into the palm of your hand. These spectrographs are based on a component called array waveguide grating, which was developed for fiber optic communication, like NBN. These arrayed waveguide gratings can be mass-produced, which makes them cheap compared to classical spectrographs. These not only allow for faster internet, but also allowed the scientists to dig deeper into space. But IPS isn't the coolest kid in school. Most widespread is the transit technique and the radio velocity technique. In the radio velocity technique, one looks for tiny shifts in the color of the light emitted from the host star. These shifts are caused by the orbiting planet. The pull of the planet ever so slightly moves the star. This movement in the star is what changes its color through what we call the Doppler shift. Due to the fact that the shift is very small, thus it requires extremely precise and sensitive instruments that measure the color or wavelength of the light. Such an instrument is called a spectrograph, but not like the previous one. This one is a lot more precise and sensitive. They are very complex and expensive to build. Typically, a normal one can be the size of a car and full of optics. That's the only downside to the radio velocity method, or else it's pretty cool. There are not many spectrographs out there that are precise enough and sensitive enough for the radio velocity technique. There are some, but not enough. However, if there was a cheaper solution, such as IPS, we would use many more telescopes to look for exoplanets, to speed up discovery and improve our understanding on how planets form and maybe answer the question of if we're alone out there, or if there's someone with us. Thank you for paying attention to my video. Hope you enjoyed it.